number 7, we have the integral of 8y raised to 7 minus 1/2 times the square root of y times dy. The integrand involves y rather than x, but don't panic. As long as the variables in the integrand and in the differential match, there will be no problems. Since the variable in the integrand is y and the differential is also y, then we can proceed in evaluating the integral. We just have to apply the theorems and observe the patterns in the variable. So the power rule and the sum and difference rule still apply even if the variable is changed. So first, let's integrate each term separately. So integral of 8y raised to 7 dy minus integral of 1/2 times the square root of y dy. Next, take the constants out of the integral. So we have 8 times the integral of y raised to 7 dy minus 1/2 times the integral of, change square root of y into its power form, so it will become y raised to 1/2 times dy. Then, apply power rule, theorem number 4, so this will become 8 times y raised to n plus 1. Our n is 7, so 7 plus 1 is 8, divided by 7 plus 1, which is 8, minus, copy 1/2, times y raised to 1/2 plus 1. Again, 1/2 plus 1 is equal to 3 over 2. 2 times 1 is 2, plus 1 is 3. Copy the denominator 2. So we have 3 over 2, divided by n plus 1, which is 3 halves. Then, plus c. Next, simplify the coefficients. So we have 8 divided 8 is just 1. So we can cancel out 8. So we copy 8 or y raised to 8 minus 1/2 divided by 3 over 2. So what is 1/2 divide 3 halves? This is equal to 1/2. Change the operation to multiplication and find the reciprocal of 3 halves, which is 2 over 3. Then, multiply. 1 times 2 is 2, divided by 2 times 3 is 6. So 2 over 6 is equal to 1/3. Or we can cancel out 2, so we're left with 1 over 3. So 1/2 divide 3 halves is 1/3. Then copy y raised to 3 over 2, then plus c. And that's the integral of number 7. So that is how you solve for the indefinite integral. Once you get the hang of it, you can omit writing several non-essential parts of the solution. For instance, we can just proceed by applying theorem number 4, the power rule, without taking the constants out of the integrals. Then we can just perform the term-by-term integration in our heads and then write the final answer right away. But for now, study and understand the step-by-step process of finding the integral. And hey, don't forget plus c.